Welcome to the Galencia Starfield Deconstruction Programming tutorial video. For those of you who are unaware of what Galencia is, let me explain here. Galencia is a brand new space shooter for the Commodore 64, which was released in this calendar year, 2017. Galencia was inspired by the arcade video game Galaga. It's a fun, addictive game, and you should check it out. One of the neat features of the game was the background Starfield simulation. It captivated me, and I could just watch it endlessly. In this video, I'm going to cover the actual Starfield simulation source code used in the game and try to explain the basic concepts of how it works. In preparation for my upcoming review of Galencia, I came across a posting in the Lemon 64 forums in which the game's programmer Jay Aldred posted the source code for the Starfield simulation used in the game. I was intrigued by this, so I grabbed a copy of it and pulled it into CBM Program Studio, only to be disappointed that it would not compile as is. You see, it was just a snippet, and some things had to be in place in order for the program to work. So I contacted Jay via email, told him I was a programmer, just not as advanced as he is, and asked him what would be required to make the program work so I could tinker around with it. He got back to me and said, "I'll make you a deal. Send me over a small program that redefines the character set along with the address of the character set data and the screen data, and I'll adapt my Starfield simulation into your program and send it back to you." Deal! So I wrote a quick little program here adapted from the source code copied from the Dust Layer website, which I had covered in a previous tutorial. Essentially what it does is sets memory address 3000 as the new character set location in memory. Then it copies all the characters from ROM to that RAM location 3000. I then filled the entire screen with characters and redefined the first character just to demonstrate it was working and sent it over to him. Jay got back to me a couple of days later, having combined his program with mine. Here is the final working product. Just mesmerizing. Before I start to attempt deconstructing his program code, I want to cover one more time the concept of shifting characters in memory. I've tried to explain this before, and some people ask me, why don't you just use bit operations like ROL, ROR, etc. That would be fine for shifting left or right, but shifting a character up or down has to be done differently. Let's take a quick look at something I've come up with. So just to demonstrate what if we were to take a basic character definition, let's just say that we've redefined the character set in memory and set it to be address 3000, and the very first character is this @ sign. Let's just use this for an example. The very first byte that's at 3000 is composed of this top line. So the bits here are 0, 0, and then 1, 1, 1, 1, 0, 0. So that's what I have here in binary. 0, 0, 1, 1, 1, 1, 0, 0. And then in hex, it's value 3C. So that's what would be stored at address 3000. And then the next byte going down would be this next one across. 0, 0, 1, 1, 0, 0, 1, 1, 0, which is 66. And then the next line, byte 3002, would be 0, 1, 1, 0, 1, 1, 1, 0, and so on, all the way down the line. So if we want to shift down this character, in other words, we want to move so that it shifts down one byte, we don't do bit operations to shift left and right. That would move it left and right. So let's look at this in CBM Program Studio to get a better understanding. Under Tools, Character Editor. So when I say shift down, I mean this: down, 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 and so or up. And then if you did bit operations like ROL, ROR, that would be shifting it left or right, and that's not what we're covering in this video. So to shift it down like that, what you end up having to do is copy what's on the very top byte and put it into the second byte, and so on all the way down. Except you don't do it in that order if you're shifting down. You start from the bottom. So you take what's at 3006, what's on this line, and copy it into 3007. So that shifts it down one, and then you repeat. You take what's in 3005, put it to 3006, all the way up till you take what's at 3000 and put it into 3001. So if we do that, let's look at, I have another page, you'll end up with something that looks like this. Now for this example, I'm just going to zero out what's at the very top to just all zeros, because for the star field simulation, we're not shifting it back into within itself. So we don't have to worry about shifting what's down here back up to the top. So that's what it looks like, and then the values shift down. So at address 3000 now becomes a 0, 3001 becomes 3C. And then if we shift it again, it looks like this. So address 3000 becomes 0, 3001 is 0, 3002 is now 3C. So you can kind of look at them at the top, down one, down again. I only did these three just to give a quick example. So imagine having stacked a bunch of characters in a column going all the way down from the top of the screen down to the bottom, and you just want to shift a couple of bits down one byte at a time. And then when you get to the bottom, you clear out the bottom row, but then you jump to the next character down. And then you continue the process of shifting it down. To simplify it even further, let's clear out this character, and I'll try to explain how Jay's program works a little bit. Assuming that we're just talking about an arbitrary address that I came up with, 3000. He doesn't actually use address 3000 in his program, but if this top row was 3000, and then that would mean the next row is 3001, he draws in at 3000 those 2 bits. Then after the raster is off the screen, this is cleared out, and then so from 3000 is cleared, and then at 3001, so he increments the pointer to the next byte and he draws it in again. And he just repeats that process. The next raster is cleared, he clears that out, and then he draws it in on the next byte down. So this is 3000, 3001, 3002. Then when he gets all the way to the bottom of this character, instead of, so this is all the way to 3007 down to here, he clears this one out, and then he goes down to 3008. Now 3008 would be up here, Now this would be 3008, 3009, and so on, A, B, C, D, E, F. And so basically it just shifts, it goes down to the next character, and when it shifts down to the end of that character, it shifts into the third character down the row, or down the column. And then when it gets down to the third, it shifts into the fourth, all the way down to the bottom of the screen. So let's take a look at the source code that I sent him, and then we'll look at the source code that he sent back to me, and we'll try to deconstruct it, how it's working, by commenting stuff out. This is the code that redefines the character set, and I extracted it from this URL up at the top. Then all I did here, before I sent this off to Jay, was I did a quick loop that put a bunch of characters on the screen. And then the very first character that's at 3000, I just made the first 2 bytes 0. So let me run that to demonstrate what that does. So you can see the whole screen now has characters on it, and if you look real closely at the top left, the @ sign, I zeroed out the first 2 bytes so that now they're blank at the top. And then that was just to prove that the characters were being redefined. And then I just copied this source and I emailed it off to Jay. And then what he gave back to me is this. So he stripped out some of what I did, but he left the dust layer portion in, which redefines the character set at 3000. And let's run it before we look at the code. One more time. And look at that, isn't that cool? Notice how some of the stars are falling faster than others. Check out the colors. You see how they're all different colors, and notice that some of the stars are twinkling or just flashing in regular intervals. They're actually not moving, but they flash. So there was a lot of detail put into this star field simulation when you start looking at it closely. Now, looking at and trying to deconstruct someone else's source code is sometimes it's a daunting task, and it was for me on this. So how I went about doing this was to essentially just comment things out before I try to understand how it exactly worked. So if you look at the very beginning, he changes the background to black. I wanted to comment that out, the border and the foreground colors to black. He then initializes the star field, creates the initializes the star screen, and then in a loop he does the star field, continues it moving endlessly in a loop. But before we get to that, I just wanted to end the program right there and show what he set up first before he did anything else. Okay, so without the program running, without all the everything in place, you can see the character sets. And if you look at these characters going down this row here, or this column, this is one character, this is the next character in line. So if this is, let's look at what that character is. So 400 is 3A, so this is character 3A. And then let's look at the next one. 428 is 3B, and let's look at the next one. 450 is 3C. So you see how they increment, 3A, 3B, 3C. So all he did was, he only needed one line going across, so 40 characters, and then he just incremented them going down. So 3A, 3B, 3C, all the way down, so that they would be in a consecutive order. And you can see that in his source code at the bottom. Here's his star field rows. This is 40 characters going across. So 10, 20, 30, 40. And then he wrote a program to fill the screen in based on this top row. And that is the create star screen program. And if you were to look at this, if you're just looking at this and trying to deconstruct how this works, it's kind of complicated looking at it like this. But just know that from this piece of code to here, all that's doing is drawing this screen. And it's setting up the star field simulation. And also notice that the color scheme's in place. So he has gray, orange, darker gray, green, blue. He has all these colors going across. And then if you notice closely, like this colon is right here, and then it's repeated down here. So there's a colon. So he's offset the stars so that, or when the program runs, that when a star is up here, there will also be one down here. They're a little bit offset. So that's the setup for the program. Now, right here, to me, I didn't know what this was doing. So I asked Jay to explain this to me, and he did the best he could. He said essentially the Commodore 64 has a raster, which is like an electron beam that goes across your screen, and he waits for it to be off the screen before he shifts any of the bits or the bytes. And that way it's smoother, and also it creates a delay effect. And then he increments a raster count. And so anyhow, let's run it again with the background color turned off and with the program back in place. So that's how it looks if you have a blue background. Now, what I started doing in order to try to figure out how the program was working was to comment a few things out, and I'll show you what I figured out. If you comment out he has set up a few pointers, what he calls starfield pointers. He has pointer 1, 2, 3, and 4. And those are going from left to right across the screen. And I'm going to comment out 2, 3, and 4. I'll leave starfield pointer 1 in, and I'll comment out 2, 3, and 4. And I think I can just do it like that. And right click and comment. And okay, and so this is the part that this part that I'm commenting out is affects how it shifts down the dots on the screen, the characters on the screen. And then the second part to that is this. So I'm going to comment this out too. And this is where it literally draws the character in place. So now that I've commented out star pointers 2, 3, and 4, let's run it just to see what that looks like. So you can see, even though I've commented out the other pointers, you can see because those characters are the same characters that were drawn across the screen in different places, that's why you're seeing that this one operation is shifting down in different columns. If I comment out Starfield 1 and re-comment in Starfield 2, it will shift it over. It'll shift it over into these areas here. So let's take a look. Let's do it that way. So if we comment out Starfield 1, uncomment Starfield 2, and do it in both places. Let's see what that does. Now, it's hard to notice, but it shifted it over one column to the right, and also it's falling a little bit faster than Starfield 1. Let's put them both in at the same time. So let's put Starfield pointer 1 in. And so now we'll have 1 and 2 running. And you'll see the speed difference. See how the first one's running down the screen slowly, and then the second one's jamming along? Now, this in itself would make a pretty good Starfield. Also notice that the stars are twinkling. So now let's go back and comment 1 and 2 out, but uncomment 3 and 4. So let's comment out 1 and 2, and uncomment 3 and 4. So now 1 and 2 are uncommented. This is where you'll notice that what I thought they would be shifted over more. We're still in the first column, something's moving right here, and in the second column, something's moving along. That was when I realized that 1 and 3 are tied together. So let's bring 1 back in. Leave 3 in and comment out 4. So now we have Starfield pointer 1 and Starfield pointer 3 in position. Notice how this one's down to here and it starts over up here. That's because there's 2 of these running at the same time almost. It makes it 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 gives the illusion that there's more stars on the screen. Rather than just having one run from the top all the way down to the bottom, now there's one, it starts halfway down. A second one starts when it's halfway down. And so that's what he's done. Also, one of the things that I noticed that this OR command right here is what turns on the bits. He's using decimal 3, which is 110 or 11 at the end. But if you were to change it like to 1, if you only wanted 1 bit in there, it will make for a thinner star. So let's run that. So now see how it's hard to tell probably, but it's 1 bit running down, and that one's a little wider. So it's a thin, wide, thin, wide. You know, if you wanted to give the illusion of even more, let's say I haven't tried this. We could try 101. Yeah, but see that, I see why you didn't do that. That is spaced too close together, and but you can see how you can adjust the program here just by messing around or playing around with these OR statements, because these are what turns on the bits at which position. So like 12 is doing something similar in a different position, and if you can play around, you can look in the calculator, in the programming calculator, and put in let's say 12, and look at what it is. It's 1100, so it's going to be kind of in the middle of the character, in the middle of the 8 almost. So now let's bring it all back, uncomment everything. Actually, let's comment it all out. Let's comment it all out. I want to show the twinkling by itself. So let's comment it all out. So now there will be no shifting. No shifting stars falling down. But let's see if we can see the twinkling like this. See, like, where's my mouse? Like right here. See how that turns on and off? It's really hard to notice. Let's look for the twinkling. It's being handled right here. So it's after a certain raster count, it will either set the static character to 1 or to 0, or it will turn it back on. And you have 2 different characters here that are statically set, that are static and just blink on and off. And if we were to comment out, some of this code here, I believe that will turn one of them off. I think we could just comment one line of that code, and that would do it. See, you got a little bit. You got this one twinkling, on, off. But now you don't have the other one turning on and off. So let's bring that back in. And let's comment in everything. Okay, so now we're kind of back to the base program, except I have the 101 in there still. That looks terrible. It looks like an apostrophe or quotation. Let's fix that. Put it back to a 3. Anyway, yeah, I just find the program mesmerizing. I love it. One thing I noticed, I think, when I turned off all of them, I'm going to turn off all of them except for one. I love just playing around with this program, just comment things out, adjust it here and there, see what it does. You know, that's part of learning, you know, learning how someone else's program works, or just figuring and tinkering with things. So now it's just going to have one of the stars falling down. And then options. When you warp it, when it goes really fast, I was thinking this would be a great simulation for raindrops. You know, maybe not quite that fast, but a little bit slower. It'll look like rain. And also, if it was white, it would look like snow. Instead of rain, it would look like snow if these were white. So I wanted to talk a little bit more about this raster thing. Let's comment it out and just run it without it, just to see what that does. Look at that. See how it's shaky and it's not smooth anymore? So that this little piece of code is very important. Yeah, that's the Starfield simulation. I'm not going to go in and try to deconstruct every line by line, but just know that all he's doing is shifting the bytes on the screen, shifting the bytes down the screen, and he's doing it in different locations on the screen. So he's shifting in that first column, shifting down one bit at a time, or one byte at a time, and then he's shifting the second column one byte at a time, shifting down. That's happening right in this code right here. In each of this little code chunks is what's doing that. And then I think it's code snippet 4, pointer 4. Look at pointer 4. Pointer 4 is adding a 2 right here. Whereas in the prior ones it's only incrementing one time. This one's adding 2. That makes it jump down twice as fast. So that's why you'll see some of the stars going twice as fast. So let's leave 3 and 4 in and comment out 1 and 2. So if we comment out 1 and 2 and leave 3, oh wait, am I not doing that right? Right here. Comment out 1 and 2 and leave 3 and 4. I'm waiting for the screen to draw. Notice how the stars are moving fast on one column, and then on the other column it's moving slower. That's because he's doing that add 2. He's jumping it down. He's jumping up the speed. Let's put it all back in. And look at it one final time here. So you can see this. There's some stars that move slow, some are moving fast, some don't move at all, some are just twinkling or just turn on and off. And I don't know, I enjoy deconstructing this program. I thought it was a fun little project to work on. I want to thank Jay Aldred for taking the time to integrate his program into mine. That was really gracious of him, and for answering all of my questions. I'll be placing the source code up on my GitHub, and it will be a link to that will be in the video's description. Thanks for watching.